So in the last class we saw regarding the data transformation. So in addition to that, how each of the features are being prepared to for ease of applying the models. Okay, so we require certain kinds of transformation in each of the following. So take for example, the data can be either categorical or numerical. So in case of when we are having the modeling methods, the numerical values can be directly applicable for modeling purpose. But whereas in case of the categorical variable, we need to either apply some kind of ordinal way, or we need to have some kind of mechanism of converting the label into a numeric form. Okay, so we have these techniques, we call it as a feature preparation. So basically a feature is a predictor or attribute or independent variable, so which has a measurable property can be studied. So basically we can have either a numeric features or categorical features. In case of numeric features, continuous or discrete, they can be directly usable by most of the ML algorithms. Okay. But in case of categorical variables, so either we can have either nominal or ordinal. So in the case of nominal, there is no natural order, but ordinal we can have the meaningful order, but it should be encoded for use of algorithms. So when a feature is there, numeric or continuous, as we can see that we can directly use. But when a feature is categorical, we require an encoding form. So feature preparation bridges the gap between the raw data and the algorithm expectations. So the features need to be clean and to bring into an appropriate scale so that the machine learning models can learn effectively. So encoding of categorical variables, we have label encoding. So we give a label a value to the non-negative integers. Okay. So either the colors can be given for, take for example here when we have red, blue, green. So we can have an integer be encoded. For red I can assign 0, green I can assign 1, and blue as 2 as per our nomenclature. Okay, so we can create a map and we can assign the values. So that is label encoding. Okay, so similarly I can have for other this one, bus we represent 0, bike we represent 0, bus represents 1, car represents 2, and train represents 3. Now next is that one-hot encoding. So one-hot encoding is same as labeling method, but the problem is that the it creates additional features, and wherever the appropriate is there, it keeps as 1, and for other features it keeps it as 0. So take for example the encoding, red as 0, green as 1, and blue as 2, implying the order. So the one-hot encoding gives that, so where it is present it gives 1, and for others it gives 0. Similarly, the red becomes 1 0 0, green becomes 0 1 0, and blue becomes 0 0 1. So there is no ordering is implied. You can see here. So we keep wherever the red is 1 and mark it as 0. Similarly, wherever the green is there, so I mark it as 1 and others as 0, and similarly for blue. So each row has exactly ones and all others are 0. So this is very easily we can do and it is in the unique way. So we can also have ordinal encoding. Take for example, when we are using the educational level, we can have some hierarchy. Okay, so we can give PhD as 1, masters as 3, and high school as 2, and bachelor's as 0. Okay, so we can also have the other way. So it should not be like this. It should show us a proper hierarchy level. Okay, so we start from the high school, then bachelor's, masters, and the PhD. So this way we can correctly code the data so that it is uh, possible. In certain cases, rather than direct utilization of the data, so we can also have a derived variable. So the derived variable can measure what it means. Okay, so we can have ratio, we can also have a difference, or we can also have the interaction. Take for example, if the price in the quantity is when I want to measure revenue, so we need to do that some kind of manipulation for identification of the total sales. Okay, so or we can go polynomial, or we can go with the aggregate category. Okay, so ratio differences and interaction gives us some kind of edge over the normal methods. So another way is that binning or discretization. So when we have a large number of data, and we need to divide each of the data into bins, that is with a range of equal ranges, so where the data is lying between the closed interval, then we assign one particular bin. So by this, the we what is that the variance can be reduced, and also reduce the noise tolerance too. So we can also call as the frequency binning, so that it is easy for us for analysis. So this figure summarizes the entire requirement of feature preparation. So we need to first identify the raw feature column as the numeric or categorical. So when the numeric is there, whether it is skewed or not skewed, we have to see. If it is heavily skewed, then we go with the log transformation. If it is not heavily skewed, then we can go with the binning or discretization. Or we can also use derived features values too. In case of categorical, whether there is a ordinal or not. If ordinal is not there, we can directly go for the ordinal encoding. If it has the high cardinality, then we can go with the one-hot coding or target encoding. So we have seen today regarding the feature transformation. Thank you.